This next topic, we're going to stick our toes in the pool labeled trigonometry. I'm not going to go through a whole lot of development for trig. If you have been able to go through review the basic algebra videos I've already produced, you have enough algebra to be able to deal with trig. Okay, trig is not that complicated. There are places in it that get complicated, but what we need for our understanding of it is not. So let's kind of go back to the beginning, and by that I mean like maybe to the Greeks, I don't know. And let's look at a triangle. I didn't do a very good job drawing that, but that's okay. These lines would be connected. This is just for discussion purposes. All right. The Greeks, centuries and centuries ago, were very interested in triangles and discovered a number of relationships. This is a so-called right triangle because one angle is 90 degrees. And it's denoted by this little box square. That means that these angles, there's three angles in any triangle. To be a triangle, it must have three angles. And all three of those angles, angle 1 plus angle 2 plus angle 3, have to equal 180 degrees. Okay. Well, this says that this angle is 90 degrees. Therefore, the sum of these two angles have to be equal 90 degrees. But that's not what I want to get to. Let's call this angle A, angle B, angle C. C is our right angle. We also have three sides, and the sides are typically lettered opposite their angle. And we'll use lowercase a here, lowercase b here, and typically in a right triangle, the long side, the hypotenuse, is always C. And it turns out that there's a relationship between these angles, or among the three angles, and the lengths of the sides. And that leads to our three most fundamental trigonometric functions. The sine function of sine wave fame, the cosine, not S-I-G-N-E, sine, and the tangent. There are three others that are the inverse of this. This is the cosecant, this is the secant, and this is the cotangent. We're not going to be dealing with those. All four of these, other than the sine and the cosine can be used to create any of the other four. But we're not going to worry about these. And we're pretty much only going to be concerned about the sine and perhaps the cosine. Well, what are these relationships? They are the ratios. The sine of an angle, and let's look at angle B here. So the sine of angle B is the ratio of the side opposite B, which is little b, divided by the hypotenuse. Well, that's handy if they're lettered, but I like to think of them, I don't know what the letters are because any lettering scheme can be used. Oftentimes even Greek letters are used in trig a lot. This is the side opposite the angle over the hypotenuse. That way I don't care what it is. That's the relationship. The cosine of angle B is the side adjacent to that angle. next to. This side is next to the angle where this side is opposite the angle. So it is A over the hypotenuse. And then for the sake of completeness here, let's do the tangent. The tangent of the angle is equal to the opposite over the adjacent. But this is the one that gets used an awful lot, the sine of the value. Again, the ancient Greeks discovered this centuries ago, and it's still good to know today. Another thing coming from the Greeks that's relative to this right triangle, it only pertains to right triangles, and that's the Pythagorean theorem. The Pythagorean theorem. I think. I'm not a gifted speller. It says that if we take the hypotenuse squared, that's backwards. Let's go forwards. If we take the square of the two sides, a squared plus b squared, that will equal the length of our hypotenuse squared. This is the Pythagorean theorem. Okay, and that comes in very handy, certainly in solving trig problems, but in practical application all the time. If you're dealing with vectors, the length of the vector can be gathered because it's oftentimes the hypotenuse of a right triangle. So doing this mathematics here. And you see that the math operators are not that complicated. If we had, let's say this side was 3 units long and this side was 4 units long, I can square these two, and the value I get here will be squared. So 3 squared plus 4 squared equals 25. But this number is a squared number. If I take the square root of that, the square root of 25 will tell me that the length of that is 5. So if my side opposite is 3 units long, my side adjacent is 4 units long, then the hypotenuse will be 5 units long. So there's an application of doing the Pythagorean theorem. We're too close to 10 minutes to continue, so I'll do at least one more video here.